Good morning, everyone. We are starting with spherical mirrors. Now, imagine I have a hollow glass sphere. This is hollow glass sphere, right? Now, a bit of portion from here to here and from here to here, right, is painted with silver. And the center of the glass is C. And this is painted over here, painted with silver. So that is why we call it silvered surface, silvered surface, and this is called also silvered surface. Now, if I cut the glass like this, or rather like this, what I have in my hand, I have one this thing, and I will be having another this thing, right? So this become spherical mirrors. So spherical mirrors are spherical mirrors are a part of a part of a hollow glass sphere of which one side is silvered, right? So we get two types of mirrors. And the other side becomes capable of reflection, capable of reflection, right? So this is called reflecting side. I'm not naming the mirrors right now. This becomes the reflecting side. Clear? Is this clear? Shall I go ahead?
Yes, sir.
Okay. Now again I am making a surface, hollow glass sphere, and say I am cutting it into two pieces. Right? So I will wipe off this portion and I'll wipe off this portion. Right? Okay. Now I will silver this surface and I'll silver this surface. Now if I remove bit by bit, don't you think this is a straight line? Very small part of a circle becomes a straight line or not?
Yes, sir.
Yes, Boidojo.
Sir, can you repeat once the line?
I said if I cut into small pieces,
Yes, sir.
the sphere becomes a combination of plane lines or not.
Yes, sir.
Therefore, we can say what? Spherical mirrors are large combination of large number of plane mirrors. Can't I write? Or you can say tiny plane mirrors. Tiny plane mirrors. Just give me one moment. I'm removing this board a bit because I want to open that door. Is the whole board visible now?
Yes, sir.
Okay.
Copied, sir.
Pratyasha,
The last paragraph copy. Sir, done.
now there are two types of spherical mirrors. One is called concave mirror. Concave mirror is a part of a hollow glass sphere, hollow glass sphere, of of which the outer surface of sphere is silvered. Is silvered. Now this becomes silvered surface. Since this is opaque, so definitely this becomes reflecting surface. Remember, reflecting surface of, of concave mirror is bulged in. When I was young, right? So I was not able to remember which should I call concave and which should I call convex. So somebody taught me cave means what? Here it is named concave. cave. So cave where you have to bulge in the thing, right? And convex mirror is that part of hollow sphere where it is also a part of hollow glass sphere. Automatically this becomes reflecting surface, right? Is a part of a hollow glass sphere of which the inner surface is silvered and outer surface is bulged out. So here and the outer surface is bulged out, acts as a reflecting surface. So the same thing will be written here also. The inner surface is silvered and the outer surface it is bulged in. Sorry, which surface is bulged bulged out, acts as a reflecting surface. See, you can find out many differences if a question is given that what is the difference between a concave convex mirror. First is silvered surface is inner in convex, silvered surface is outer surface, reflecting surface is bulged in, reflecting surface is bulged out. There will be more. There will be more. This is a converging mirror. This is a diverging mirror. I cannot show you right now because you have no idea about the ray diagrams. I don't know about Boydurjo, but Pratyasha, you should make the mirror using a compass. If I find in my test any ray diagram made made freehand, half 50% of the marks will be deducted of that particular question. Let me know once you have noted.
So noted.
Okay, good. Vidurjo,
Noted, sir.
now let's understand few terms. Okay, few terms of related to spherical mirrors. Few technical terms related to related to spherical mirrors. Spherical mirrors. Now, first term is pole. First term is pole. Represented by P. Right? So, say this is silvered in. Now we will name this mirror as M1, M2. And this mirror is M3, M4. And this is silvered outside. This is the center of the sphere. This is the radius of the sphere. Therefore, this is also the radius of the sphere. Now, pole is nothing. Here is the pole, right? The geometrical center of the geometrical center of the reflecting surface reflecting surface of spherical mirrors are called poles. Now, if this is P, I will name it P dash. Right? Here, in adjoining figure, adjoining figure, here in adjoining figure, mentioned as mentioned as P and P dash for convex and concave mirrors respectively. Clear? So this becomes your convex mirror and this becomes concave mirror. They have drawn two separate diagrams, which is also good, but I am drawing in one only. It can be drawn in one also. Now, what is center of curvature? center of curvature denoted by C. Here also it is mentioned as C. The center of curvature, the center of curvature is the center of the center of not not center, the center is the center of that hollow glass sphere of which, right, it is not up to this now, it is little bit, uh, though I have made almost half of the sphere, right, of which the center of curvature is the center of that hollow glass sphere of which the spherical mirror is a part. Right? Third is principal axis. It is not principal PLE, principal axis. It is a straight line. It is a straight line which joins the poles and centers of curvature now here pole means mentioned as center of curvature, here mentioned as, you have to write all this, you are here mentioned as capital C. It is the straight line which joins the poles and centers of curvatures of the spherical mirrors. Right? Okay. I will write it R1 and R2. Also, here mentioned as, yes, Pratyasha, what is the principal axis of M1, M2, of the spherical mirror M1, M2? Which is the line? Name of the line? Pratyasha? Huh?
Sir,
It is a straight line which joins the poles and the center of curvatures. Centers of curvature of the spherical mirrors. Here mentioned as, yes, Boydujo? Any idea?
Sir, PC.
Very good. PC and we have to take P dash C.
P dash C. Yes, sir.
Clear?
Yes, sir.
Pratyasha, clear?
yes, sir.
It is clearly telling na beta, joins the poles. These are the poles.
Yes.
And since I have taken the common center of curvature, right? Clear?
Yes.
Number 4 is Number 4 is radius of curvature. Curvature, it is denoted by normally R, right? Here I had to take R1, R2 because I have taken two separate mirrors, concave and convex, both at the same time. So what was center of curvature? Can anyone tell me?
Sir, what is center of curvature?
Yeah.
Sir, C.
Oh, 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 oh. How do you define? It is written on the board still.
Oh, sir, it is the center
Sir,
of hollow glass sphere from which the spherical mirrors are made.
Correct. Correct. Now, what should be the radius of square curvature then? If you are taking the center of curvature at the center of the glass, hollow glass sphere, of which the mirror is a part. So the radius of curvature will be radius of that spherical hollow glass of which mirror is the part. Clear? The radius of curvature of a spherical mirror is the radius of that hollow glass sphere of which the mirror is a part. Note it down. We'll revise it. Don't worry. We'll revise it. Note it down. I'll take 5 minutes gap. Yes, I'm back. Is it noted?
Sir, last line.
Pratyasha, Boydus jo beta draw the diagrams neatly.
Sir, I
Yes,
have
sir.
Oh,
noted.
Noted,
okay,
sir.
okay, I'm coming. Waiting this close. Now we will understand what is focus. See, this is a concave mirror, right? concave mirror AB. Center is, geometrical center is somewhere here. So this is your pole. And say this is it's a big sphere. So this is its center of curvature. So the line joining center of curvature, and whenever you go on the other side, you should show this. You can show it by bold lines also, they don't mind, but it should be appropriately shown as dotted lines, right? I have already told you that a spherical mirror is a large number of combination of large number of tiny what plane mirrors. Am I right? Now suppose rays are coming from incident rays are coming from infinity. Now after reflection, oh, yes, this will be a line, but dotted. Now this is your angle of incidence. Am I right? Because if we let's understand what is a tangent. Understand it properly. Suppose this is a circle. Here, this is a circle with center C. Suppose there is a point P here on the circumference. If I join CP and draw a line perpendicular to it, this is called tangent. Clear? That means if I take this part, small part of the mirror, it is a straight line and this angle is 90 degrees. So therefore, this ray, say this ray is PQ and this ray is P dash Q dash. So incident ray PQ for this angle is I, angle of incidence. So it follows the law of reflection. So it will go somewhere here. Here angle R and here. Right? This is denoted by focus. Now we will have to define focus of concave mirror. Clear? Here what we do, we take an assumption that since infinity, it's coming from infinity, lines coming from infinity or incident rays coming from infinity, they are parallel to each other. Right? So focus can be defined for concave mirror as, or I will write focus of concave mirror the parallel or the incident rays, the incident rays coming from infinity, infinity reflect from the reflecting surface, reflecting surface of a concave mirror, of a concave mirror following, this part is important, following laws of reflection. Now see, it is actually meeting. It is actually meeting. I will draw once more about convex mirror, but let's take what happens in convex mirror. Convex mirror is something like this. This is the pole and this is the principal axis. Say, I am drawing it rough hand. Right? Now, if this is the normal, it will diverge the rays. Right? If another ray is coming like this, right? So it will get diverged, get diverged. This will go like this. So it appears to get diverged from this point. Actually, it appears to get diverged from this point. So, but here the lines are converging. The reflecting rays are converging. Converging means meeting at a place. Are in fact infinity reflect from the reflecting surface of a concave mirror following laws of reflection, and reflected rays reflected rays actually converge. Reflected rays converge and actually meet at a point on principal axis. Axis, and this point is called focus of focus of concave mirror. Now, from here, we have got two important points. Important. First, the concave mirror is a converging mirror. Another difference is a converging mirror. See, because suppose this is PQ and this is R. say this is ST and U, and this is say F. Now, in case of convex mirror, they are appearing to get diverged from this, but actually they are and getting diverged, right? So concave mirror becomes a converging mirror and convex mirror becomes a diverging mirror. And second point is, can you see the rays are actually meeting here, reflected rays? Yes, Boydurjo,
Yes, sir.
the reflected rays, this is the reflected ray, right? This is your R. Clear? So they are actually meeting or not?
Yes, sir.
So
But
at the
in case of,
focus.
huh?
At the focus.
Yeah, at the focus, they meet at the focus. This is written, huh? And this point is called focus of the concave mirror. Now here the point is, first of all, the concave mirror is diverging the incident rays. Diverging, sorry, converging means meeting at a point or making closer. Clear?
Yes, sir.
Yes.
And diverging means separating them away, right? So concave mirror is a converging mirror and convex mirror is a diverging mirror. Now point number 2. Can you see here? Arey yaar, I have made the ray diagram direction wrong. Please do not complete the ray diagram after I check it twice. Right? Now here the rays are actually meeting. Now if I ask you, Pratyasha, do you think the ray QR and ray TU will ever meet?
No, sir.
Because they are diverging rays.
Yes.
That means, and if I produce them backwards, they meet at a point. They appear to meet at a point, and that is why I have made it dotted. Clear?
Yes, sir.
Is it clear?
So the image which will be formed will be virtual.
Virtual, correct. That is a later part of story. First of all, since this is meeting actually at the focus, that means the concave mirror, these are not given in the book. The concave mirror has a real focus. And in that case, we'll write virtual focus. Okay.
Sir,
Yeah.
can you once again explain the diagram of the concave mirror, the markings and all, because I couldn't understand the reflected rays and the incident rays.
What?
Can you say which ones are the reflected and incident rays in the concave mirror, because I couldn't understand them. The in the concave mirror focus part.
Have I mentioned angle I?
Angle I. Sir,
Can you
yes,
see I have written angle I?
yes, sir. In the topmost and
Okay.
down part.
Yeah. Can you see I have written angle R also?
No, sir. That one.
Here.
Oh, okay, sir. Angle R.
Here. Is that clear now?
Okay, sir. Yes,
Now
sir.
definitely the rays which are coming to the reflecting surface are the incident rays always.
Okay, sir.
And which are going back after reflection, they are refracted rays. You want
Okay.
me to teach you laws of reflection once more?
No, sir.
Then, and I told you, this becomes a normal, which I have shown you as a tangent. If this is a tangent, this becomes normal. AC is the normal. Here, CB is the normal.
Okay, sir.
Now P dash Q dash is the incident ray which gets reflected as Q dash F, and PQ is the incident ray which gets reflected as QF and meet at a point called F.
Okay.
That point is called focus. Now, one more thing.
Sir, why are the reflected rays meeting at the focus only, but not any other point?
If the lines are parallel, these are experimentally verified, beta. If the incident rays are parallel to principal axis of a concave mirror, they will certainly meet at focus.
Okay, sir.
Wait a minute. Pratyasha, why you are asking stupid questions? I will say it is a stupid question to for anyone. Pratyasha, didn't I tell you right now? Right now I explained that if I take this mirror, first of all, right? This is your hollow glass pair. Am I right?
Yes, sir.
Okay. Now I am making mirrors from here. So this is your concave mirror or not? Right. Now if I take tiny parts, they will become plain mirror or not?
Yes, sir.
Hello.
Yes, sir.
And also, I told you that line joining a tiny plane mirror perpendicular to it is the normal or not,
Yes, sir.
right? Now any line or any incident ray which comes will follow the angle of incidence is this, so angle of reflection will be this, and it will meet here only. It has to. Mathematically also, geometrically also it has been proved. That is why I am saying, if you want me to prove or yourself to prove, make a proper circle using a compass. Take and draw a tangent at any point. You have to draw a tangent. I told you how to draw a tangent at any point of circle, right? If I have to draw at this point, I will be joining this and this first, and then draw a 90-degree angle. That will be the tangent at that. So from there, you will be clear that what is the angle of incidence. Keep the angle of incidence and angle of reflection. Right? Same here also. Angle of incidence and angle of reflection. Same, and you will find the reflected rays are meeting at focus of concave mirror only. Clear?
Yes.
So once again, I am telling you these rays are parallel to the principal axis. Now, principal axis can be drawn like this also. It is not necessary that it is limited in CP. It can go beyond the mirror also. Right? In this case also. It can go beyond the mirror also. Now, the rays which are coming from in infinity, we assume that they are parallel to each other. Now, if they are parallel to each other, they will make same angle of incidence or not? Yes, Pratyasha?
Yes, sir.
Right. They will make same angle of incidence. So definitely they will follow the law of reflection and meet at one point only. Because in every case, the angle of incidence and angle of reflection are same. Clear? Now, since this is actually getting diverged, they are the rays are becoming closer to each other, right? So that is why this is known as converging mirror. On the other hand, you can see this mirror is a diverging mirror, right? The concave mirror has a real focus because the reflected ray actually they are meeting. tell me, can this ray TU go beyond the mirror? Yes, Vaidurjo.
So TU.
Yeah, this is T. Okay, I will write 1 second. This is T and this is U.
Can this go beyond the mirror
Can
or
you
not?
expect that this TU is coming from F?
Yes, sir.
No.
So no, sir.
Once you have silvered, this portion is opaque, na?
Oh, yes, sir.
Then it will
So
appear to come from F.
But it is not actually coming from F.
Yeah, that is why it will have a virtual focus. এই জন্য তো বোঝাচ্ছি আমি তখন থেকে এগুলো ক্লাস 9-10 খুব কঠিন হয়ে যাবে। এইটা ভালো করে রিভিশন রাখবি তোরা। আমি এত বকবক করবো না কিন্তু ক্লাস 9-10 সোজা মিরর ফর্মুলায় চলে যাবে। I will not be going for ray diagrams also. Now, can anyone tell me what is the focal length? Boidurjo, can you notice in the concave mirror figure a small f?
Yes, sir.
So it is the distance between what?
It is the distance between the focus and the pole.
So that is called focal length. Pratyasha understood? বুঝেছিস?
Yes, sir.
The distance between the pole and focus of a spherical mirror is called its focal length.
Sir, so we can say that half of radius of curvature is focal length.
That is proved. We will prove that. In your school, they have not shown you, na?
Yes, sir.
I will show you here. But I don't know whether I will be able to, because do you all know similar triangles?
Similar what?
See, focal length is radius, half of radius of curvature, right? That is true. But it can be proved mathematically also. I mean, geometrically also. Let me see whether you can understand that proof or not. Obviously, then I'll go for that, otherwise not.
Sir,
Yes.
the definition that I said that the distance between focus and the pole, was that correct?
Yeah,
Okay, sir.
absolutely correct. The distance between the focus and pole of a spherical mirror is its focal length, denoted by smaller. And the distance between center of curvature and pole is radius of curvature. Chalo, we will prove. Pratyasha,
Yes, sir.
we will prove.
Okay, sir.
It is not given, na?
No, sir.
But I will prove it for concave only, okay? Because it will not be asked to prove. It is out of syllabus. I will not go much out of syllabus. The proof is out of class 8 syllabus, even class 9 syllabus.
Sir, copied this one.
Pratyasha, you don't copy that convex mirror and other things. You'll get confused later on. These are not to be copied. I mean, this one, this I was just explaining. The main thing is here, whatever I have written, and this diagram, of course.
Okay.
চলে এলো হরেক মাল 100 টাকা।
স্যার বসিরহাটে ওই লোকটার অন্তত উৎপাতটা নেই, এই হরেক মাল বিক্রেতার উৎপাদ এখানে নেই।
Right? Can I wipe this off?
Yes, sir.
Definition is better. This is for your understanding only. Now, can you note down the definitions? Definition of focus of concave mirror from your book, page number. Acha, Mr. Boidurjo.
Yes, sir.
Note it down. I'm dictating. The
Okay.
focus of a concave mirror. The definition should be as per book.
Yes, sir.
Value addition, you can do this. The focus of a concave mirror is a point on the principal axis.
The point
Is a point, not the point. Is a point on the principal axis Yes, Pratyasha. Writing.
Yes, sir.
The focus of a concave mirror is a point on the principal axis at which light rays incident to the principal axis meet within brackets converge. After reflection from the mirror. Boidurjo, can you send me a photograph what you have written?
Sir, can you please repeat that the focus of a concave mirror is a point on the principal axis, then?
At which the light rays, Pratyasha, you can consult your book. Go to page number
Yes, sir,
89. This gentleman is not carrying his books. Page number 89, last two lines, and then page number 90.
Yes, sir.
sent, sir.
Oh, you have sent. focus of a concave mirror is a point on the principal axis at which light rays incident to principal light rays at which light rays incident parallel to principal axis. Incident parallel to principal axis
Yes, sir. Meet
meet at a point after
at
reflection from mirror.
meet at a point after reflection from mirror. Yes, sir.
Yeah. Meet at a point. Meet within brackets you have to write converge.
Yes, sir.
Converge. It's converging, na? Pratyasha, have you written?
Yes, sir.
Have you written after looking at the book?
No, sir.
Have you checked?
Yes, sir.
Have you checked the page number 89?
Yes,
So
sir.
fix it. Check it out and write exactly what is written there.
Sir, I have written.
So can you send that portion in the group so that Mr. Boidujo, who is not carrying his books, can refer to that and write the correct definition properly? Can you help him out? Similarly, the focus of a convex mirror is a point on the principal axis on the principal axis, right? On the principal axis, at which at which light rays incident incident parallel to parallel to principal axis appear to meet appear to meet within brackets or diverge from the mirror appear to meet after the reflection from mirror. After the reflection from mirror. Okay, important. Number one, convex mirror is a diverging mirror. Number two, convex mirror has a virtual focus. Imaginary. Virtual means imaginary. It is not real actually, because the incident rays are not actually intersecting each other. But it looks like that they are getting diverged from that point. Or to meet at that point. Appear to meet. Is this clear?
Yes, sir.
See, the reflected ray cannot go behind the mirror, na? Hello.
Yes, sir.
So take it for granted, convex mirror will never be able to make a real image. It will be always diminished. Diminished means having a size lesser than the size of object and virtual image. Better remember. Achha, what type of image the plane mirror makes?
Virtual.
Why you are saying virtual?
Virtual, yes, sir. Virtual and inverted.
Virtual images are not inverted. I am not talking about lateral inversion. I am talking about vertical inversion. Right? Real image are vertically inverted. Boydurjo, are you getting something or it is becoming a bouncer of Shoaib Akhtar?
Sir, no, sir, I understood that you were saying that the plane mirror.
First of all, plane mirror can do a sidewise inversion. Like right hand appears to be left hand and left hand appears to be right hand in the mirror. Okay.
Yes, sir.
That is called lateral inversion.
Yes, sir.
But you don't see your head downwards and leg upwards. Can you see that?
No, sir.
But if you go in front of a concave mirror, you can feel that also.
Okay, sir. So can also be vertically inverted and laterally inverted too. And depends on.
Both. But up to class 10, we take only vertical inversion in numericals.
Okay,
In
sir.
11th, we go for total inversion, lateral as well as. See, here we will be having an object as a line, right? In class 11, you will be given numericals like iron loop squarish is kept on the principal axis at certain distance, where its image will be formed and how much will be total inversion. Total inversion will be inversion in area. If it is increases, so area will increase by. So that time we will go for vertical inversion also and lateral as well. Multiply the both, right? The square will either become a little square, smaller square, or a bigger square. That you will understand how they enlarge and reduce. Can we go for focal length now? Hello?
Yes, sir.
Is it written?
Yes, sir, I've written.
Boizurjo, is it written?
Yes, sir. Noted.
Noted. Give me 2 minutes. Let me finish my tea. Boizurjo, is your father at home only? Boizurjo,
Yes, sir.
is he at home?
Who, sir? Father?
Hmm?
Yes, sir.
Can you quickly go to him and ask him if I can call him after the class or not? I need
Okay.
to consult something about something.
One moment.
Last day you said to me that my father is downstairs and his ECG was going on.
Yes, sir. I know.
And when you knew, then you should have told me, na, a person having ECG, can he talk to me over phone?
Sorry, sir. Sir, my father says that he can talk with you after the class.
Okay, not an issue. Okay, now the next term comes focal length.
Sir, one thing I had to ask.
Yeah, tell me.
Sir, I was saying that the image formed by the convex mirror.
Hmm? I could not hear you properly. Boydurjo,
Hello, sir.
yes, what you were saying actually. I could
Sir,
not hear it properly.
oh yes, sir. Sir, I was
Hmm.
saying,
Hmm.
in the case of an convex mirror, the
Hmm.
virtual focus leads to formation of images that are smaller in size than the object itself, right?
To certain extent, yes. Yes, I agree with you. Number of times I am drawing the image, you should draw the image. The distance between the pole and the focus of a spherical mirror is called the focal length of the mirror. There is one more term, focal plane, which I am not going to explain because you all will get confused. Noted?
Yes, sir.
Yes, sir.
Now, relation between focal length f and radius of curvature are of a spherical mirror. This we are going to prove. This I found it's easy. You will understand. I will prove it for. It is generally f is equal to r by 2, right? F is equal to r by 2, and we are going to prove it for with help of concave mirror. Suppose this is a concave mirror, okay? And say this point is pole. So this is the, and say this is the center of curvature. Clear? Now, there is a incident ray which is parallel to principal axis, parallel to principal axis. Is that clear? will pass through the focus. This point is focus. And this is pole. Clear? Will pass through focus. Now, draw a line. What is happening? Say this is a ray, incident ray. Let's make the mirror a little bigger. This side I don't need. Suppose this is an incident ray A, B. Now CB becomes the normal, which I explained, no? This is C. And this point is B. Right? Now let this angle be, this is called alpha. Obviously, this angle will be angle I, and this angle will be angle R. Since we have already said that, no, this thing, that this follows laws of reflection, right? Now here, we can write
Sir, what is that symbol called, you said?
alpha.
Al,
This symbol, this is called alpha. Remember, this is called beta, and this is called gamma. Right? Now, according to law of reflection, this angle I is equal to angle R or not? Clear? Also, AB parallel to CP, and BC is the transversal. Therefore, angle I is equal to angle alpha, alternate angles. Am I right?
Yes.
sir.
This is my equation 2, and this is my equation 1. Oh.
Sir, which one is equation 1? The angle I is equal to
Angle
R.
I is equal to angle R.
Okay.
Now, clearly see this. In triangle BFC, angle R is equal to angle alpha. From 1 and 2 we can say na, if I is equal to R and I is equal to alpha, that means angle R is equal to angle alpha,
Yes, sir.
right? Therefore, this becomes an isosceles angle or not? CF is equal to FB. Clear? Can I write CF is equal to FB?
Yes, sir.
Actually, I have gone a little wrong. Wait, should have placed this at in middle, which I have not done. Hence, it is looking little odd. Now it's okay. CF is equal to FB or not?
Yes, sir.
Now think of a situation. If I, this is the, what is the aperture? What do you mean by aperture? The entire length of the circumference of the hollow part of circumference of the hollow sphere, which is made as a spherical mirror, right? Which is formed into a spherical mirror, is called, from which reflection can take place. So this is called aperture, right? This entire reflection length or area, whatever. Oh, AB I have already used. So let me use M dash. Clear? So this is called aperture. Now check here. If I reduce the aperture up to this line will become this. If I reduce more, this line will become this. Are you getting my point? What is happening? FB is becoming smaller. Is this clear? Hello.
Yes, sir.
So that is why we can assume one thing. It's assumption, right? For smaller apertures, for small apertures, FB is almost equal to FP. This is my equation 4. Clear?
Yes, sir.
Or you can write it directly this. Right? Now we have what? CF is equal to F, FB. Clear? Is equal to FP. Or I can do it like this also. FB is equal to FP. Right? Now from this, can I write CF is equal to FP?
Yes, sir.
Have you understood this? This is
Yes.
3 actually. This is equation 3 and this is equation 4. Better understand this for once, cool-headedly. So CF is equal to FB, FB is equal to FP. Can I write CF is equal to FP? Can I write CF is equal to FP?
CF is equal to FP. Yes, sir.
Yeah, CF is equal to FB and FB is equal to FP. Therefore, CF is equal to FP or not?
Yes, sir.
Right? Now, can I write CP is equal to CF plus FP? Because this CP is CF plus FP. Can I write?
Yes, sir.
Hello?
Yes, sir. Can be written.
Yes,
CF
sir.
is equal to FP. So I can write CP is equal to CP is equal to, in this place I will write FP plus FP, which is 2FP. Clear?
Yes, sir.
Now what is FP? It is F or not? And what is CP? It is R.
Yes.
So I can write R is equal to 2F or F is equal to R by 2. Yes, Pratyasha, understood?
Yes, sir.
This is beyond your syllabus.
Sir, this is geometrically proven that F is equal to R by 2.
What?
This is geometrically proven that focal length
F
is
is equal to R by 2. Yes. Optics is nothing but a game of geometry only. Please note down each step. If any doubt is there in on any step, ask me and then write. Don't copy and paste. See, in my test, I might give you to this derivation. Derive F is equal to R by 2 with a suitable diagram. Is this understood?
Yes, sir.
Yes, Pratyasha, have you understood this?
Yes, sir.
Why I have considered FB is equal to approximately FP? Because for smaller aperture, this ray will be close to FP. Assuming that FB becomes FP. Therefore, CP becomes 2FP and done. Is it noted properly?
Yes, sir.
Pratyasha noted?
Yes, sir.
Okay. Now we have certain rules for making ray diagrams. Number one, the object should be kept in front of mirror, that is reflecting surface.
So can you please repeat?
The object should be kept in front of mirror. Like, suppose this is a concave mirror, okay, convex mirror, sorry. The object, can we keep the object here? Suppose this is the object AB. What will happen? This is a silver surface, no? So, what is correct? The object should be kept in front of the in front of the reflecting surface. This is right. And this is wrong way of putting the object. Hey, in your book, it is written object is kept in front of the reflecting surface on its left side. But the reflecting surface is on its right side. It should not had be this way. The reflecting surface should be on the right hand side of the object. This is concave. Number two, the object is always kept the object is always kept. The questions which will come from this topic, write any two rules for making ray diagrams. Kept on the principal axis. Principal axis such that it is perpendicular to the principal axis and its foot touches the principal axis. It means you should show all this using diagrams. This is the principal axis. This is the mirror. This is pole. Say this is center of curvature. This is focus. Object is somewhere kept here. Or I will make the object little larger. It should be perpendicular. Now A and B. B is the foot touching the principal axis and this is angle is 90 degree. Clear? The third rule is not that important. We should be taking at least two convenient rays. Two convenient rays to construct a ray diagram. Ray diagram is the essence of optics. Now, what do we mean by convenient rays? We will discuss in next topic. First, it should be in front of the reflecting surface. Reflecting surface should be on the right of the object. Reflecting surface should be right of the object. Second, the object should be placed on the principal axis in such a fashion that it is perpendicular to the principal axis. Number one. And number two, the foot B touches the principal axis. Clear? This is the head and this is the foot. This is the head of the object. Head of object. And this is the foot of object. Pratyasha, is your father at home? Hello. Pratyasha, are you there? Hello.
Hello, sir. You're audible.
Right? What happened to Pratyasha? Pratyasha, am I audible? Pratyasha, please respond.
Sir, I'm having problem in sound system.
Throw that in the nearest pond and get a new one. I said, is your father at home?
Yes, sir.
Sir, are you saying anything?
No, I'm not saying anything. Is this noted?
Yes, sir.
Sir, I noted.
Yeah, I'm coming. Yeah, before I go for something else, one by one. Where is the mathematics book of WW? This is supposed to be the book. No, this is not the book. Pratyasha, after. Pratyasha, I'm talking to you. Pratyasha,
Yes, sir. Yes, sir.
अरे यार reply when I'm calling you. My question is, after mensuration, have they done anything in the school?
No, sir.
If I am not wrong, open your mathematics book.
Yes, sir.
Go to the
Yes, sir.
index, contents.
Yes, sir.
Which was the first chapter they had completed?
Compound and simple interest.
Acha, then they started the session with simple and compound interest.
Yes, sir.
Okay. Then percentage and its applications.
No, sir. Personal applications is revision chapter.
Okay. Then they directly went to algebraic expressions.
Yes, sir.
Then they did understanding shapes.
Yes, sir.
Then they did construction of quadrilaterals.
Yes, sir.
Then they did mensuration. Am I right?
Yes, sir.
Can you note it down in your copy? Test on mensuration, construction of quadrilaterals, understanding shapes, algebraic expressions and identities. Can you note it down somewhere in your copy and send me a photo so that I can write later on?
So can you repeat the chapters?
Mensuration, construction of quadrilateral, construction of quadrilateral, understanding shapes I will not take. I'll take algebraic expressions and identities, obviously. And percentage and its application, 4 chapters. Percentage and its applications, algebraic expression and identities, construction of quadrilaterals, mensuration. Have you noted? Hello, Pratyasha, have you
Yes,
noted?
sir. Noted, noted.
Take a picture and send to me.
Mobile ka daw.
Now, in point number 3, I have underlined convenient race, right? Now, let's see what are the convenient rays, basically. Or this is also called rays of convenience. So, convenient rays. A ray passing through center of curvature, or you can write an incident ray. An incident ray, passing through center of curvature reflect is reflected back along the original path. Means it is very simple to understand why they are saying so. If this is P, this is C, always write this FPC. Now I'll take a ray through C. This is the incident ray, right? You know, suppose this is the incident ray AB, and you know this CB is normal. CB at this point is normal. So it will be reflected back only.
Okay, sir.
Understood?
Yes, sir.
Number 2, an incident ray parallel to principal axis will pass through focus after reflecting from spherical mirror. So this is the spherical mirror. Any ray. Now this one has to be principal axis. This is P. This is C. And this is F. A ray is passing parallel to principal axis after reflection passes through focus. Third ray. Just reverse this path. Just reverse this path and you will get an interesting thing, that an incident ray passing through focus becomes parallel to principal axis after reflection from spherical mirror. Has these been discussed in the school? Yes, Boydurjo, are you there?
Yes, sir, I am here.
Why you people are so silent?
Sir, no,
I
sir.
am asking a simple question and you people are not answering. Has this been explained?
No, sir.
See, I am reversing the path of this. Now a ray is passing through incident ray, passing through focus. After reflection, it will become parallel to the incident ray, the principal axis. Sorry. So these are the three convenient rays. We will be starting. Tasha, you have not sent me the chapters which I asked you to write,
Sir, I've sent.
but I have not received at my end. Is it showing double tick?
Yes, sir.
Okay. Okay. Just note this down. First, a ray passing through center of curvature will reflect back along the original path. I have forgotten to original path. Right? Again, an incident ray parallel to principal axis will pass through focus after reflecting from spherical mirror. Now, if I reverse this direction, this will be automatically reversed. Now, here what? The ray, incident ray is passing through focus, so it will naturally become parallel to the principal axis. Draw these diagrams neatly. We will be starting with formation of images with concave and convex mirror tomorrow, and tomorrow we'll be finishing the light. Satyasha,
Yes, sir.
last year there was an accident. Hope this year goes smooth.
Yes.
And I am in a mood to start class 9 physics.
Okay, sir.
Right? Class 9 physics by December end. December Jan. Yes, Boyjurjo, are you listening?
Yes, sir.
जो भी घूमना घामना है 9th में घूम लो, 10th में मैं किसी को छुट्टी नहीं देने वाला हूँ. 9th का मैथमेटिक्स भी स्टार्ट करूंगा और 9th का फिजिक्स भी स्टार्ट करूंगा मैं 8th में ही. I have the books, so I don't have any issue. I'll talk to your parents today. Get a separate copy for class 9 physics to start with. Boydurjo, be organized.
Okay, sir.
The main problem with you is you are very unorganized. Too much. Have you noted all this?
Yes, sir.
Then bring the
Satyasha?
diagram.
Diagram is important. Boidurjo, to I don't know how he has drawn the diagrams.
Sir, using scale, I have a steel scale here.
But what about the spare? You should be using compass also.
Compass, sir. Yes, sir.
Chalo, unfortunately, you didn't know. But next time onwards, do not forget to take your pencil box, complete pencil box. And for my case, mathematics and physics books. I don't know about others. Should be there with you. And copies.
Okay, sir.
Even for some hour if you are going. And that day is a class day. Pratyasha noted.
Yes, sir.
Can we end the meeting now?
Yes, sir.
Okay, thank you everybody.
Thank you, sir.
Bye.
Bye, sir.